So we've done the chain rule, we've done the product rule, now it's on to the quotient rule. The quotient rule is what you're going to use when your function looks something like this. So where with the product rule it was u times v, for the quotient rule it's u divided by v. That can either be a divide sign or it can be over and in a fraction. So in this case, your quotient rule will look something like this. So, similar to the product rule, where you had to work out u du by dx, v dv by dx, you're going to do the same thing here, except how you use them is what's different, the formula itself. So let's go through an example. In this case, what is your u going to be? X. And what's your v going to be? 2x plus 5. Now you can work out du by dx, which would be what? 1. And then dv by dx, which would be 2. Now we make use of the quotient rule. So v du by dx minus u dv by dx all over v squared. So v, 2x plus 5, times du by dx, 1, minus u x times by dv by dx, 2, all over 2x plus 5 all squared. So when we simplify it, we get this. 2x minus 2x is 0. So 5 over 2x plus 5 all squared. That's it. That's it. You don't need to expand because it's just going to make everything longer. It's not really simplifying. But there you go. That is the quotient rule. That being said, can you try this question for me, please? So, same thing as before. We label u, we label v, we find du by dx, and we find dv by dx. There. You make use of the quotient rule formula. So v times by du by dx minus u times by dv by dx all over v squared. And now it's just a matter of simplifying. So after simplifying, you should get this. X cubed bracket 4 cos 3x plus 3x sine 3x all over cos squared 3x. That is the most simplified version. One more question I want you to try. This one for me, please. Same thing as before. We're going to start by labeling u and v. So u we label as sine x. V we label as e to the power of 2x. Du by dx therefore would be cos x. And dv by dx would be 2e to the power of 2x. Type or plug those into the quotient rule equation. v du by dx minus u dv by dx all over v squared, like that. Now, after fully expanding and simplifying, you should get e to the power of 2x bracket cos x minus 2 sine x all over e to the power of 4x. Now it says find the, blah 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 has a stationary point at P. Find the coordinates. Stationary point is when your gradient dy by dx is equal to 0. So now you're going to make all of this equal to 0. To make my life easier, I'm just going to copy it over and equal 0. So now you would have e to the power of 2x cos x minus 2 sine x equals 0. So e to the power of 2x equals 0. And cos x minus 2 sine x equals 0. So here, x has no solutions, no sol. And then here, cos x is equal to 2 sine x. That's after I've taken it to the other side. So actually, you know what? Let me write it like this. So I do that, and then take the 2 sine x to the other side. Now I've got two trig functions. I have cos and sine. I don't want that. I only want one. So I'm going to move this cos there. I'm going to move that 2 there. So a half equals tan x, which means tan x is equal to 0.464. That's to 3 significant figures because my range or my interval for x is from 0 to pi. So I'm working with radians. Okay, we've got x there. We've got x. And now plugging that back in to find y should be 0.177. And those are your coordinates for P. Like that. Okay? There you go. Quotient rule.